All right, so let's take a look at the solution to problem number 15 on our free fall problems. So we got the ball and this drop from a building. It takes 6.8 seconds to hit the ground. What is the height of the building? So me personally, I was always taught to kind of draw a little diagram. Kind of helps me sometimes figure out what's going on here, especially as these problems get more complex. So the ball is dropped and is falling that way. Well, this is a ball that is in free fall because the only thing that is affecting the motion of the ball once it leaves the hand is gravity. And that would be true even if the person threw the ball down. But the key here is we say it is dropped. So that means the initial speed, the initial velocity is zero. It didn't have any starting speed going down. It was at zero and released. Then the ball accelerated because gravity is accelerating, pulling it down. We know how long it takes to get to the bottom. What is the height of the building? Well, we want a distance, and we want a distance in the y direction here because we're talking about the up and down component of motion, not a left and a right, not a horizontal, not an x. We're talking about a y. So it doesn't seem like I have much here in terms of the givens, but there is something else that I didn't write down, and that is we do know the acceleration, which is due to gravity, negative 9.81 meters per second squared. Okay, so I want to find a delta y. I wanted to find a distance in the y. So I'm going to go up here to my kinematic formulas. Look here. Well, this obviously isn't it because I don't know the starting height and the final height. This is a velocity and acceleration and time has nothing to do with distance. Okay. Oh, now here I've got a delta y, 1/2 at squared, initial velocity and time. Let's look. Do I have enough information? Do I have an acceleration? I do. It's the acceleration due to gravity. Do I have a time? I was given the time it took to hit the ground. Do I have an initial velocity in the y direction? I do. I know it's zero because it was dropped. And once again, I know the time. So it seems like this is the kinematic formula that will allow me to solve for my unknowns. I got delta y, 1/2. I always like to write g because in this case I know it's the acceleration due to gravity. Okay. Now this term here obviously just becomes zero because 0 times anything is 0. And when I solve this, I get about negative 227 meters. Okay, that is part A. For B, what is the velocity of the ball when it hits the ground? I want a final velocity. I want a velocity at a given point of v when the y is whatever that is right there. Well, now I know what the y is. I know that the y changed 227 meters. So I know a distance in y. Let's see. Oh, this is still just position. Velocity in y is initial velocity in y plus g plus acceleration times time. I could maybe use that, couldn't I? Because the velocity in the y direction, I know the initial, I know the acceleration, and I do know the time it was moving. Well, I'm going to check all the formulas here. Once again, I'm still looking for a velocity in the y direction. Oh, well, this doesn't have anything to do with velocity except for that initial, which I know is 0. Here's a velocity in the y direction. 2 times the acceleration. I know the acceleration. I know it changed now by 220. I know the y is 227 meters. And I know the initial is 0. So I could use this one or this one to solve for the velocity in the y direction. I'll take this one. I'll do the simplest one here. Velocity in the y direction at any point is whatever the initial velocity in the y was plus gt. I know the initial velocity in the y was 0. I know the acceleration is due to gravity. Oh, this is going to be easy peasy. And I get about Now, I'm going to call that negative because I said that here the acceleration was negative, calling that the negative direction. So that's going down. So my velocity in this case is going to be a negative velocity because I'm going in the direction that I've assigned to be negative. So this ball is going about 67 meters per second when it hits the ground.